Hi class, today we are going to learn about double angle formulas. So yesterday we learned about compound angle formulas where it's either sine of A plus B or A minus B and then cos and tan like that as well. Today we're going to be able to do formulas like these. So sine of 2 theta, cos 2 theta, tan 2 theta. Okay, so there's actually just the three that we're learning. It's just that cos 2 theta has two different versions that work. So we know that sine 2 theta and 2 sine theta are not equal. It's not like the distributive property where you can just move it around. So we need to come up with a different formula for what 2 theta means. So for this first one, we can actually just develop it using our compound angle formula, where A is theta and B is theta. So if you look at the compound angle formula for sine of A plus B, you would just get sine theta cos theta plus cos theta sine theta. So notice that's the exact same thing, sine times cos and cos times sine, so it's just equal to 2 sine theta cos theta, okay? So sine 2 theta is 2 sine theta cos theta, okay? Cos 2 theta, in the same way, can be developed to be cos theta minus sine theta. Okay, so notice that this is just cos squared theta minus sine squared theta. All right, so sine squared theta can be rewritten using the Pythagorean identity as 1 minus, oops, I meant to put minus there, as 1 minus cos squared theta. So then this can all be rewritten as 2 cos squared theta minus 1. Okay, another way we can get it, we can get again to cos squared theta minus sine squared theta. And we can use the fact that cos squared theta is just equal to 1 minus sine squared theta. And then subtract another sine squared theta. So we could also represent cos 2 theta as 1 minus 2 sine squared thetas. Okay, so which representation we use will depend on what's more useful to us. It'll depend on whether we know what cos theta is or if we know what sine theta is. Okay, finally, tan 2 theta turns into 2 tan theta all over 1 minus tan squared theta. Okay, so just like the compound angle formulas, these will be given to you in your test and your exam. All right, they're in your textbook, so you can refer to that or to your note to use them. So in this first example, we're given the right side of the equation and we turn it into the left side. So 2 sine pi over 8 cos pi over 8. So 2 sine cos, that is from the first one, sine 2 theta. So notice that theta is equal to pi over 8. And this is also equal to just sine of 2 theta. So it's equal to sine of 2 times pi over 8. So that just becomes the sine of pi over 4, which we know from our special triangle is 1 over root 2, or root 2 over 2. All right. This one we know comes from the tan 2 theta, so we can recognize this as tan 2 theta, where theta is equal to pi over 6. So this is just equal to tan of 2 times pi over 6. So the tan of pi over 3, which from our special triangles is just root 3. Okay. Now we're going into a bit of a more complicated problem. So again, you'll need to refer back to your equations to figure out which one is most useful for you. So this gives us that cos theta is equal to negative 2 over 3. So they want us to find out, and we know it's in the first revolution. So they want us to determine cos 2 theta and sine 2 theta. So for cos 2 theta, we have two different options of which formula we can use. Okay, we can either use 2 cos squared theta minus 1. Okay, if we go back to it, we can look here. We can either use 2 cos squared theta minus 1 or 1 minus 2 sine squared theta. Now, in the question, we were only given what cos theta is equal to, not what sine theta was equal to. So we should just use this one because we already have all the information we need. Okay, so we substitute in that that's equal to 2 cos squared theta minus 1. So 2, and then cos theta is minus 2/3, and we square it and subtract 1. So then you just use your calculator, and you find that that's minus 1/9. Okay, so we already have solved this first one. But now we need to find sine 2 theta, which isn't so easy because sine 2 theta is equal to 2 sine theta cos theta. So we know that this is minus 2/3, but we don't know what sine theta is. So unfortunately, we have to go back and do some work to find what sine theta is. So we know that the cos value is negative. So we're actually going to have two different answers here because it could terminate in quadrant 2 or in quadrant 3. So we have to consider both cases. So if this does terminate in quadrant 2, remember that if this is x over r, so our radius is 3, this would be negative 2, so we have to find this y value in order to find sine. Okay, so to find the y value, it's just the square root of 3 squared minus 2 squared, because we're just using Pythagorean theorem. So that gives us root 5. Okay, so in this case, that would be root 5. And in this case, it would be negative root 5. So we have two cases to consider. Okay, so case 1, which I'll use the blue for because that was the first quadrant. First one, in that case, sine 2 theta is equal to 2, and then sine theta would be root 5 over 3 times negative 2/3. So you'd get minus 4 root 5 over 9. And then our second case is if it terminates in quadrant 3, then sine 2 theta would be equal to 2. And then sine theta in this case is negative, so negative root 5 over 3 times minus 2/3. So your solution here would be 4 root 5 over 9. So one is positive and one is negative. You just need to indicate the understanding that there are two possible solutions because it only gives us that theta occurs between 0 and 2 pi. So we don't know if it terminates here or here. So we present both cases. Okay. The last question is a little bit abstract. It asks us to develop a formula for sine of x over 2. Now, what we need to consider beforehand is that x over 2 is the same thing as half of x, right? And if we do 2 times x over 2, we get back to just x. So that's something that we have to consider. So we need to go look at our double angle formulas and say what thing when we double it will give us a sine x over 2 in the answer. Okay, so notice here that we would have a sine and a cos. That doesn't really help us. But here, this cos 2x here, if we make theta x over 2, then we would have a sine squared x over 2 here, and we would be able to isolate for sine of x over 2. So if that's a little abstract, just watch how I do it, and hopefully it will make sense to you. So if I actually do cos 2x, okay, but then I would have 1 minus 2 sine squared x. Okay, but I don't want that to be an x here. I want that to be an x over 2. Okay, so therefore I need this x to be an x over 2 as well. Okay, you don't have to copy that red if it's confusing you. It's just kind of there to help explain. So I'm going to say cos 2 of x over 2. Okay, so now my theta there is x over 2. It's equal to 1 minus 2 sine squared x over 2. So now I get just cos of x is equal to 1 minus 2 sine squared x over 2. Okay, so now how this is useful is that I am able to isolate sine of x over 2 and come up with a formula that I could always use for sine of x over 2. So I just need to isolate sine of x over 2. So I get cos x minus 1 equals negative 2 sine squared x over 2. Okay, and now I need to divide both sides by negative 2. So I would get 1 minus cos x because of the negative divided by 2 is equal to sine squared x over 2. Okay, so now I just need to do a square root, and I'll do it over here just in a different color. So then I get that the sine of x over 2 is equal to plus or minus the square root of 1 minus cos x all over 2. So this is a formula that I developed myself. So again, let's go over the concept of why we chose cos 2x. We chose cos 2x because when you get the right side, you're going to have a sine x that you can isolate. But you want that sine x to be x over 2, not x, because that's what the question was asking for. So therefore, what the x has to be here is x over 2, so that over here you'll have another x over 2. So 2 times x over 2 just gives me x. Then I have my x over 2 here, and I move everything around. Okay? So, but the major concept here is that we'll be using these different double angle formulas. So there's 1, 2, 3, 4 of them to solve problems just like you did with the compound angle formulas. Okay, so thanks for watching, guys. Hope you learned lots.